Hey, Mboss here, straight into it today. I want to quickly follow up my last video on make anything machines with two new points. First, I'm going to simplify the MAM even further, and then I'm going to show a limited quality enrichment make anything machine. Last week I showed this as the simplest design, easily doable in Space Age 2, I imagine. A few days later though, I came up with the problem. It's going to give you the most benefit in the early game when you really only need a couple of stacks of a wide variety of items. A full logistic system is not until yellow science, I think maybe purple too. I'm not sure because I always do purple first for the Assembler 3, beacons, blue belts, that sort of thing. So exactly how useful would this be if it needs basically a completed science build just to unlock its parts? The question I want to ask is, can I make it earlier in the game? Yes, I can. Okay, this one didn't actually take much work at all. And the most advanced items here are the combinators and circuit wires themselves, which are available at red-green science. Everything else is red, automation science only. Check the previous video for the full functional description. I'll just go through today what I had to change to get it to work without a bot network. Firstly, the current supply status. Instead of the Roboport output, chaining all the output chests together is simple enough. These two chests are instead the input into the original Combinator 1. This video, instead of the line of combinators, I've stacked them into this little 2x3 block here, just to make it look pretty. Secondly, I did change the philosophy slightly. Self-supply. Because I can't just have bots provide every possible ingredient into a supply chest, it needs to be able to feed itself from the MAM outputs. This inserter chest loop allows the right-hand chest to self-supply the intermediate products we need. One last difference, every time the recipe changes, there are leftover ingredients that need to be ejected. This isn't a problem for a few to be in there, but we can't allow the raw plates and plastic to gradually accumulate in the self-supply chest. To prevent this, I control these inserters here. Each one checks the supply for their specific product. When there's any iron plates in the supply, this inserter is disabled, and so on. This MAM, and every one after this point, also has a new feature I've put in. Thinking about why you want one of these, to concentrate the effects of your first modules and quality, to improve the effectiveness of the whole mole, you actually don't want it to halt once it finishes its recipe list. So instead, after the filter, this guy, which removes the negative items from the queue, there's another constant combinator. I call this one the idle request. It adds one to the queue of one particular item. Adding it here means no matter the current stock level, it will never go negative. But if the requests change, any actual item off the queue is prioritized over it. I think a good candidate here is modules. This setup can only do speed module 1s because I can't actually make blue circuits with this, but future ones have a speed or prod 3 in their idle request. So, does making it this early bring any additional downsides over my previous design? There's two. The main limitation to this one is you can't just fill the recipe list with everything you could possibly need. I've limited it to 3 raw inputs, so that means no recipes using steel, stone, or bricks. And also, obviously, at this stage of the game, no fluids. If you wanted, you could add steel and stone in on the right here, but there's not really a huge benefit because you will still run into the second limit. The second limit is the full MAM request list here. The number and quantity of items you want to supply, it has to all be able to fit in the one iron chest. Not steel, because early game. If everything can't fit in this chest on the right, you've got no way of controlling which products make it through into the self-supply chest. So it will eventually jam if an item it needs is stuck in the output chest. So what about speeding it up? Obviously, an assembler 2 once you get them, and whatever early modules you can afford, but really you're going to need to stack or chain these together. There would be nothing wrong with just placing several of these next to each other, but because this is pre-bot deliveries, you're going to have to fish through a half a dozen iron chests to collect your stack of belts. You can easily place a second one above to share the supply chests, but you'd be better off doing something like this guy. Okay, how about 4 assemblers? Here's the same early MAM straight into a train wagon. It's still pretty boring. The only difference is you need a locomotive and a station to actually read the wagon contents. Also, you can simplify by loading the raw plates directly into the shared wagon. Obviously, limit the inserters so we don't cause a jam. I'm calling this design done. You can definitely build or make anything at Green Science. It's not the fastest, but it works. Okay, on to the main event. While it's obviously not the final design, here's a simple demonstration of a make anything that once it's finished its normal request list, goes about upcycling modules to higher qualities. What are the extra steps this actually needs? So first I took a standard MAM. Here's its request list. That's step 1. I then needed to add an enrichment loop. So the next step is to prioritize something to recycle through a quality loop. I've got a recycler taking from the MAM self-supply chest with max quality modules. Its feed is controlled by these paralleled combinators here. If there are less than 10 uncommon red circuits, it starts recycling normal speed 1 modules. If there's less greens than reds, it also allows blue circuits to be recycled. I was working on upping it to speed 2, but I've pushed that into the next build, so at the moment it just enriches a small amount of blue circuits, but they aren't used yet. The only other step required is I rejigged the idle request. If everything is full, it is assumed that there is enough quality 2 items to make a single uncommon speed 1 module. After it's done this, the recycler will fire back up again, so soon the production queue will be swamped with lower tier requests again, as it tries to resupply the recycler demand. These combinators I've only started on, but they show how you would add if cases to the idle request. For example, if there are enough rare quality greens and reds, add a priority over the uncommon speed 1 and instead push out a speed 2, well, not a speed 2, a rare speed 1. In the full 2.0 space age release, this would benefit from a different logic, as you would hugely increase the efficiency by putting quality in both of these machines, greatly increasing the number of craft cycles where quality is rolled. Currently though, there's a few glitches with how quality recipes are handled with the janky mods, so I won't be able to do that until space age. What's really needed as well to simplify further are the circuit conditions. I need combinators to be able to test for something like filter out everything at uncommon or below. For example, this will be easily doable in space age, but not yet with janky quality. This setup anyway will gradually supply a full chest of uncommon and some rare speed 1 modules, but more importantly, it proves the model for higher tier modules and items. Unfortunately, watching this one work, I don't think I'm ever going to make this in a real game. It's just too slow for it to ever reach the higher tier modules. What if I scaled it up though? Here's a mental design that really is just to prove the point. Features. Okay, so this one is focused purely on circuits. So it does green, red, blue circuits, rolling into building speed modules at the highest possible quality. I did try the janky EM plant mod as well, but I couldn't get it working in combination with the recipe read-write combinator. So I'm stuck with assembler 3s for now. What are the extra things I added? The structured blocks over here on the left show you how to start accumulating a trickle of higher quality tier items. Look at just one section. It says if you have less than 10 uncommon blue circuits, add 1 normal speed module 2 to the grinding request. All these grinding requests are paralleled together on this green wire, and set the requests for these 2 chests feeding the recyclers, noticeably outside the speed beaconed area. This whole design still wouldn't need 2 recyclers. 1 is definitely enough to support the whole build. That doesn't quite get you all the way there though, as you've probably been thinking about this too. To have a chance at going up 1 quality tier, you have to go back 1 step on the production chain. So where do the uncommon or rare speed 2 modules come from? Those will still need to be assembled. So their requests have been added to the MAM on the right. I'm still working it gradually up to quality 4 and 5. You can see the levels I'm at now. But when it starts to slow down, I add the next tier speed 2 module in, and it all kicks off again. In space age, both the better handling of quality products and the new decider combinator will mean that this can probably be done a lot more simpler. I'll be able to use any item of quality level X to filter the whole inventory into staged quality levels, with each level feeding the one above. Also, I'm so keen for the new decider combinator too. The new interface will almost get us up to defining case statements, like if-then logic. It won't completely get us there. It will actually be more like PLC ladder logic coding, which is 100% a land I'm comfortable in. It's still going to take maybe 20, 30 more minutes before this builds up the buffers to produce its first legendary tier 3 speed module. So there won't be any simple run by this and pick up a couple of stacks. To produce high quality at sufficient speed, it's going to need to be at least 10 times bigger than this. Now, here's the problem with a MAM for quality. If I was to design a setup with 50, 100 assemblers, we've defeated the whole purpose for a make-anything machine. Why are we designing this? Its main goal was to replace a sprawling mall. It's no longer a tall design anymore. The design efficiencies would come from specializing into clusters with better beacon layout and possibly direct insertion. Also, even just the modules, beacons and assemblers I use in this build would take hundreds of hours to generate. It's unlikely that a design like this would be able to bootstrap itself before you reach the end game anyway. It's not going to be quite that bad in reality. MAMs built around EM plants and foundries will work more than double this speed. And also, once quality modules can go in both the assembler and the recycler, you will get more crafts, rolling quality chances. Maybe this is how you churn out a wide range of things at moderate quality levels. But your module build will be better off as a dedicated design. Okay, to close out, what did we learn here? This one shows the principle, proves that it can be done, but quality enrichment is not best suited to a make-anything machine. It has its uses for the standard, maybe one per surface base building mall, but if you want more than one module a minute, you're going to prefer a dedicated, calculated ratio build. I learned another thing about quality. This was the demo where the resource requirements finally sunk in. If this builds a module less than once every 10 minutes, just how much will be required to uniformly increase quality on a base? I made this, a couple of weeks back I laid out this. This is a 2.7 kiloscience per minute base. Everything here is legendary. Why did I think this would be achievable in a real base? I guess I've deeply learnt scrap. I've designed make-anythings with new assemblers, but I've barely tipped my toe into quality as a mechanic. Enough about that though, it was still a success. I showed a way to build a MAM without robots or logistic network, and only up to blue science, because trusting Arendelle, logistics networks may not be fully available on Novus. I wouldn't put it past him to have suppliers and requesters on 2 different planets. Well, I'm sorry to say too, but that's probably me until release now. By the time this video comes out, I'll be travelling for work. I'm off to visit my real-life spaghetti factory. I'm not going to be back until after the embargo's been lifted either. By then, all the big names will be putting out tutorials and let's plays and guides, and we'll all be drowning in details. I hope you've enjoyed my little deep dives, and I do look forward to finally playing this game for real, and maybe putting up some designs when I get back. Thanks for listening. I'll catch you around.